Should we start now?
All right. So thanks everyone for coming. Um, we'll go ahead and get started. Um, go ahead and the designated presenter can go ahead and share their screen.
Can you all see my screen?
Not yet. I don't see it. Does anybody else? Oh, there we
There
go.
we go.
Got it.
Okay, now it's working.
Okay. So, welcome everyone. We are a team from a computer system security lab at Indian Institute of Science, Bangalore. In this presentation, I will present our work, Privaros. Our paper concerns the problem of privacy in the age of drones. End-user drones are now commonly available for a few $100s, and it is predicted that this use case will grow even more in the future. Drones are equipped with sensors such as camera and GPS, which poses threat to individual privacy. Unfortunately, regulations regarding the use of drones are either rule use in various countries, and there is a lack of mechanism to enforce privacy policies on drones. This is where our work comes in. While the problem is challenging to tackle in its entirety, we focus on a subclass of drones which have a reputation to protect. As a result, there is no incentive for these companies to operate a rogue drone, a drone with a malicious intent. In fact, they have a strong incentive to comply with the local privacy regulations. However, even in this setting, we need mechanisms to enforce privacy. This is because delivery drones visit various host airspaces as a part of their delivery route. Each host airspace may have different privacy needs. The responsibility lies on the guest delivery drone to prove to the host airspace that they are in compliance with the privacy requirements of the host. Moreover, e-commerce companies may contract out the drone operation to the third-party delivery service. Although e-commerce company may require drones to comply with certain hardwares and software requirement, these delivery services may not be entirely trustworthy. In this paper, we contribute Privaros, which is a drone software stack with mechanism to enforce privacy policies specified by the host airspaces. Privaros adds mandatory access control policy enforcement to Ros, which is a middleware in robotics and drone platform. Privaros runs on the guest delivery drones and enforces the host privacy policies. It uses hardware attestation on the guest drone to prove to the host airspace that the drone is in compliance. Trusted hardware is not a far-fetched idea. In fact, many upcoming regulations, such as Digital Sky, which is proposed by the Government of India, requires commercial drones to be equipped with trusted hardwares and associate cryptographic keys. Drones can be identified by its public key, which is registered with the country's aviation authority. Now we'll see how we envisioned our policy to be enforced with Privaros, and later I'll give you examples of privacy policies which the host can have. To begin with, the host airspace specify their privacy policies and communicate these to the aviation authority. When a drone fleet operator wishes to send a drone on a delivery route, the drone contacts the aviation authority with its identity and a proposed drone a delivery route, and also presents a hardware-based attestation to its software stack. In particular, a drone must prove to the aviation authority that it is running Privaros enabled software stack. The aviation authority looks up its database and responds with a set of privacy policies uh, of all the host airspaces the drone will encounter on its delivery route. Note that we are assuming the policies will be geotagged with the host airspace's GPS coordinates. The drone loads all these policies on a local storage and then start its delivery. When a drone approaches a host airspace, as determined by the GPS coordinate, a Privaros agent running on the drone triggers the loading of the corresponding host privacy policy. Privaros MAC enforcement then enforces the privacy policy. Upon the request from the host airspace, the guest drone can prove to the host via hardware-based attestation that it is running Privaros based software stack and that the host policy is being enforced. This is optional since the drone has already proved to the aviation authority that it is in compliance and the host trusts the aviation authority. And the final step, of course, is entering the airspace and delivering the product. So now I will go through the example policies. Here I'll just give one example policy. Consider, for example, a drone that transmits its video and image feed to an external entity. This may be a cloud server or that makes a real-time navigation decisions for the drone, or it could be a ground-based remote control operated by an untrusted ground-based operator. The host may require that all privacy-sensitive objects in the drone's camera feed, such as people faces and car registration plates, be obscure before they are transmitted out of the drone. In Privaros, policies are specified as communication graph. The node of the communication graph are applications that run on the drone. The edges denote communication that is allowed via inter-process communication sockets, shared memory, and so on. In this case, you can see the communication graph specifies that the camera output must pass through this green trusted application before being consumed downstream, such as the navigation software or any other network facing software. In Privaros, we use trusted application to declassify sensitive information. In this case, the trusted blur filter application is entrusted with the task of identifying sensitive objects such as faces and blurring them suitably. We rely on host to identify these applications to perform the job of declassification. For instance, we do not attempt to verify that the faces have been properly blurred. Rather, the goal of Privaros is to enforce using mandatory access control that applications communicate as specified by the uh, uh, provided policy, that is the communication graph. Thus, for instance, a camera application cannot directly send pictures or video to the navigation software or any other network facing application. Now, let me go over the basics of AppArmor. AppArmor is a Linux security module for enforcing Mac. It is a whitelist model where programs are confined using policies. Main drawback of vanilla AppArmor is that network checks are coarse-grained, that is, only allowing or disallowing the network connection. This is a problem because at the sockets send and receive LSM hook, the recipient, even if it is running locally, that information is not available. Now, coming to the basics of ROS, I'll quickly go through these. So, ROS is a piece of middleware implemented as a library that is linked with the application. Applications running on a ROS platform publishes a message under a topic, such as camera, in this case, publishing to a topic camera output. Applications such as Navigator can subscribe to this topic. Ros uses a dynamic discovery protocol offered by the DDS to match up the publisher and subscribers. Once the matchup has happened, Ros establishes direct network socket-based communication via the underlying operating system. As it stands, vanilla ROS does not perform any security checks. It is easy to spoof messages, impersonate application, and inject a message. To address this issue, secure ROS is developed, which encrypts the communication between applications. Also, prevent obvious attacks such as message spoofing, message injection, and also authenticates application. To show the shortcomings of SROS, let's take an example as shown in the figure. Here, camera application is publishing to two, two topics with the same name, that is the camera output, with different types. Here the types are imaginary, just for the example. The primary goal of camera output status type is to monitor the camera operating status. Since SROS uses application name to look up the application certificate, we can replace a benign camera status application with a malicious application, and we can still use the benign camera status certificate. Let's take another scenario. uh, if a host requirement is that no network facing application should directly subscribe to camera output image type, it could instead require that camera status should pass through a trusted application, that is the let's say a scrub status which performs sanity checks. One way to implement this in SROS would be to decouple different types with different topics with different types. So here in this case, we'll have to change the camera output to make it into two different types, two different topics. One can be image feed and another one can be the status feed. This will require application code, and this will basically require us to modify the application and also to regenerate the manifest. And also the introduction of trusted application, since the applications are not written in such a way such that they will communicate with trusted application. To perform the redirection, it is not possible without modifying the existing application. So, Privaros enhances these shortcomings. First, we'll look into the app armor part. So, we need three additional things in the policy. So, first is we need to add a label. This can be a hash of the binary so that we can perform a hash check. The second is we need a way to specify if an application is trusted or not. And the third is specifying application to which the current process can communicate to. Remember the problem of network checks where at the level of LSM socket send and receive message, the recipient information is not available. In order to solve this problem, what we did is we attached a process identifier and we propagated it down to the network stack. And then while receiving, at the receiving end, we perform the check. So this is how we were able to um, reduce the network checks to fine-grained, that is specifying to which process the current process can communicate to via the network, via the sockets. Coming to the Ros modification, to perform the redirection, we need the ability to send commands to all the applications in a domain. Therefore, we make all the applications subscribe to one topic. Let's call it the flow controller. We did this in the RCL CPP layer. Um, uh, uh, we make the RCL CPP node subscribe to a default topic to receive commands. This can be done in RCL also, and in R or in RMW also. But for the prototype, we did it for RCL CPP. Now the question comes, who can publish to this default topic? So the answer is only the trusted application can publish to this default topic. These trusted applications are specified via the app armor. This check is performed in the DDS where the publisher and subscriber is created by doing an IOCTL call to the kernel to check the app armor profile if the current process is trusted or not. In the SROS manifest, if topics are not present, then application cannot publish or subscribe to it. So, without any change, we cannot perform the redirection. Therefore, what we did was we over provisioned application with temporary topics so that we can redirect flows via the trusted applications. So for this, during the manifest checks, in we temporarily we have a fixed set of topics. We do a bypass of such uh, uh, we bypass checks for such topics. So the main thing is how to change publisher and subscribers which are bound to topic once they are created. In the application layer, we need to modify code in order to change this. So this is obviously not a feasible approach. In the DDS layer, we simply cannot replace the publishers and subscribers by creating a new one. This is because these publishers and subscribers they have the callback functions of the applications which are invoked whenever a new message is received. So therefore, in order to change, so the application still, so if you want to perform the redirection, we cannot modify the publisher and subscribers of the application. The application doesn't know the topics are changed, but still the redirection happens. This we were able to achieve this by modifying the readers and the writers. So here in this case, we modify the data writer and we also modify the RTPS writer. Uh, and so if we replace the data writer and the RTPS writer, means as well as the readers, then the problem is the connection will get terminated. So if the application themselves won't reestablish the connection, then the connection won't happen. So uh, the problem here is if the connection is terminated, then who will initiate the means connection? To solve this problem, we leverage the DDS discovery protocol, so which is means advertised periodically, so that new connections will be formed whenever we replace a data writer with a new one. So this concludes our ROS changes. Are there any questions?
Anyone in the audience have any?
Or like we can have one at the end also.
So this isn't really a ROS specific part of the question, but just kind of thinking about how this is laid out. Is there an expectation that a host airspace would extend beyond the actual physical boundaries of that particular location? Because otherwise I could easily see a route that would, say, skirt alongside a sensitive location and be completely free to use whatever imagery it could come up with, as long as it doesn't cross the line, even if it's able to take very high resolution photos in that direction.
So, Roger, may I answer that question? This is
Absolutely.
Vinod here. Yeah. So it's a very good question. So and if you were to consider essentially like cylindrical zones in some sense, this problem would arise. Where in some sense, you just have a cylinder rising up from the boundaries of the area. But so different countries have different regulations. One of the things that Digital Sky, which is the one that we have studied a little bit, is proposing. Digital Sky is a standard proposed in India. Is that around certain regions, for example, airports, they're proposing conical regions. Okay, so it's like the airspace, the restricted airspace, rises like a cone from the location that's to be protected. So as you approach, you'll have to go down the boundary of the cone. So when you're really close to the probably only when you're a few meters above the ground can you be really close to the boundary. As you rise higher and higher, you're supposed to be further and further away. Does that make sense? I was trying to
Yeah, I see perfectly what you're talking about there, which then leads into the second thing that I'm wondering, because if you do have that capability, then that means that adjacent places could potentially have overlapping areas that would be subject to both policies.
Absolutely.
Is there any problem with contradictory policies?
Excellent question. This is not something that we have investigated yet. Our first attempt here was to provide the basic capability to enforce MAC. I think there's a lot of potential here to investigate, policy languages and how to investigate conflicts between policies. Should policies just be described in terms of GPS coordinates, or should you consider the pitch and the yaw of the drone? All of these things are questions worth investigating. We haven't yet looked at them. So I don't have good answers for you right now.
Anyone else? Well, I have a few. Could you go back to maybe the slide about the redirection, the topic redirection? So I glanced at a bit of your patches a while ago, and one of your modifications, like you stated in RCL CVP, is that that you had to account for this this switching or this sort of indirection, whereas prior you had the camera driver, the navigation stack communicating over this camera output topic, and you sort of inject your filter application sort of seamlessly in between as a sort of a middleman to provide the sensor sanitization. This is like a kind of common task that we maybe do in the Ros ecosystem by explicitly denoting the node and remapping the topics directly in something like Ros launch. Are you under the constraint where like you'd have to hard code the topics in the application binary as opposed to using like a launch configuration file to dynamically change these based on incorporating the filter node in the launch file?
So for that redirection via the topic, you need to relaunch the application. Is that right?
If so in Ros you can like swap topics, but yeah, that does involve like a destruction of and construction of a data reader and data writer, as far as I'm aware. But it'd be sort of unusual to I see like this as some kind of merit here that it would be very uh, seamless for the user in that like they have some sensitive data flow and they just label it as such, but being a little bit more explicit would simplify a few things in that you wouldn't necessarily have to modify the DDS layer and the RCL layer with this indirection. The data flow could be made explicitly represented in the launch file, and then that could also be easily translate into the DDS access control policy. The other thing is here you describe a scenario where you're correct that that in DDS you could reuse the same topic name, and it could be and over that topic could be published multiple IDL types or different topic types.
Yes.
So you're correct. There's nothing that like enforces you what the topic type has to be over a certain topic name, but that would be considered abnormal, I think, in the Ros. Like you would start getting lots of logging errors, and a developer would normally try to avoid ever double using a topic like that because of this. It's not a thing that Ros normally supports. I think like Ros, because it's all distributed now. I think Ros kind of work, but I'm not sure a single camera process node could publish over the same topic of two different types. I imagine it might issue an error, but the subscribers could sort of work it out. But yeah, that's just something that maybe a remark, but cool.
Yeah, true. So basically, like the publishers still can have the some multiple publishers with the same topic name, but the application won't crash in ROS 2.
Okay. And then the modifications you had to do with AppArmor, I see you had some patches to that, and the Linux security module. So that's for having the Linux security module enforce the inter-process communication restrictions.
Yeah, yes, specifically to the network rules.
That seems pretty novel there. Do you want to dive a little deep there?
So yeah, so the main problem in vanilla AppArmor is it's not expressive. So basically, you can just specify whether an application can communicate via the network or not. So here in our settings, since we are dealing with stopping the communication among a different processes, so and a ROS uses a socket-based connection. It can be a UDP or TCP. So we wanted a method in which we can specify to which applications current process can communicate to even via the network sockets. So here in this case, if we specify that camera cannot talk to the navigation software, and also So then, in the policy, we won't have the navigation software. So the connections will be dropped, like at the LSM level. The packets will be dropped, even if the camera application tries to send a message.
I was actually wondering on this particular one here, it's showing disallowing, sending that to the navigation software and disallowing sending it to a network facing application. Would it be possible for a developer to create a different node that did not meet those criteria, which could access the camera data directly and then forward it on to something which was not intended to have it?
If it is there, this problem comes this is basically will be an information flow control problem then. So here, since we are using mandatory access control, then yes.
No. So actually, let me answer that. So in this particular platform, which is a mandatory access control based platform, the onus of rejecting bad flows falls on the policy developer. So, when you have a platform like this, you're expected to have written down these policies, almost like an SE Linux policy, and look for bad instances of flows. So, in some sense, the onus of ensuring that no such leaks exist comes via policy analysis. Now, we are working on an extension to Ros that allows you to do this dynamically. That's what Rakesh is saying, which allows you to do information flow control by tracking labels at runtime. But that system is not yet ready. So as it stands, you will have to analyze the policy, ensure that there are no such applications that leak data like this without going through a trusted application. But you're right. I mean, if there was a node between the camera and the navigation software that didn't go through the trusted blur filter, yes, you would have a leak of data. But that now becomes a policy analysis question, making sure that the policy that you're going to install on the drone satisfies your local security constraints.
To get back to the AppArmor, when it's inspecting the socket connections, supposedly over the local host network, between two processes co-located on the same host, normally I think that's something already that the DDS access control plugin would already kind of inspect. It would verify the credentials and permissions of the other node and decide whether it wants to initiate the communication. Is there another advantage aside of having this this discretion in the Linux security module rather than just the DDS transport? Is this something that could also be used to control whether any other side channels like shared memory access, or I think you mentioned shared file access in your paper. Is this something that you could use for shared memory transport as well?
So just to be clear on the question, DDS itself is just not enough for the protection, right? Because these are means at the end processes, and they can let's say open up a socket connection, and if they are written in such a way that they can directly communicate among themselves, then they can still use the network sockets to communicate. Then for such scenarios, the DDS means alone is not enough.
Okay, so yeah, you're operating under a threat model where the applications may have access to additional libraries to initiate a sort of side channel communication over the network. Okay.
Right. So one of the main contributions of this work was to ensure that protection happens both at the ROS layer as well as the this access control happens both at the ROS layer as well as the OS layer. But an important point design consideration was to ensure that the trusted computing base is the OS alone, so that the only functionality that we leave to ROS is actually uh, deny any flows that already exist. But the OS can deny flows even if they are allowed in ROS. So ultimately, if the OS says no, even if ROS allows the flow, that's not allowed. So we went to great pains to actually ensure that the TCB, the trusted computing base, is the OS and the OS alone. To our knowledge, we have not extended the TCB to the ROS layer. So that's something that I think we placed a little bit of thought on. We didn't want to extend that to the application layer.
The flow control topic. So could you explain what was the role? Every node has to subscribe to this flow control topic. Is that what's
Yes.
doing the indirection?
So at the end, these are distributed processes. So if you want to, let's say, send any command, we have to send the command to everyone, and then like in the message, it can contain to which specific process it belongs to. So for that requirement, we had to make sure that all the applications subscribe to one topic, so that we can send commands to that topic to say, hey, you need to change your publisher from this topic to that topic.
Okay, so this is informing which topic to indirect to. All right.
Yeah. So moving on to our evaluation, we now present a snippet where we illustrate the performance impact of redirecting flows through a trusted application as required, for instance, to enforce blur exported policy. Our evaluation platform is NVIDIA Jetson TX2, which is equipped with ARM Trust Zone. We reflash the software stack on this board with Privaros. So in the paper, you can find the evaluations with a micro benchmark. So let us consider a basic setup where the camera directly communicates with the navigation software. This is the base case, and the latency of this communication is 8.1 millisecond, and it consumes about 750 milliwatts of power. Now let us introduce redirection. To study the base cost of redirecting flows through another application, we direct the flow via the null blur filter that simply serves as an identity function. We note that this increased latency, in this case about 115%, this is inevitable, and we view this as a cost of privacy enforcement. Power also increases by a small amount, about 1.8%. We now consider a blur filter application that performs some computation on the input image stream. As a result, the latency further increases and power consumption goes up by 8.1% compared to the base case. Note that this is highly domain specific depending upon the nature of the computation that happens within the trusted application. Thank you for your time. If there are any more questions, we can have a discussion.
For the impact that sanitizing the data head. This was done over. This was implemented with a node over the local loopback, and not necessarily composed nodes or using shared memory transport. Correct?
It was over a loopback. So
Okay.
trusted app. Yeah.
Sorry. Go ahead. Gianluca, did you have any questions?
Yeah, I was curious about what Vinod said about the analysis that they want to do on the mandatory access control policies. So you said you want to use labels, right? And you're working towards that?
That's right. So we are looking at dynamic information flow control on top of ROS. But that's not this paper. This paper was just Mac.
Yeah,
So that's,
absolutely.
yeah. So that is work in progress right now. So, just to give a little bit more context, right? I mean, one of the pain points here with Mac was that although you can enforce these policies of this kind, the onus is on the developer to ensure that the policy ensures secrecy and site-specific security goals. Instead, what we wanted to do was to have this dynamic notion of tags, so that if you read something that's sensitive, you also get tagged as sensitive, and so on. And so finally, when the data is being exfiltrated from a sink, at that point you can do your enforcement. So it's much more dynamic rather than having to come up with these static communication graphs and so on. So that motivated us to work on this dynamic information flow control based approach for ROS. And we are working on top of a system called CamQuery for that, which provides such tracking within the Linux kernel, and we are extending it into the ROS layer also. So we want to bring the notion of ROS topics together with the notion of information flow labels at the OS level. So that's the project, but we are still a ways off from completing it.
What's the Linux project? Cam something?
Oh yes, it's called CamQuery. CamQuery is the one that we are using that extends another system called CamFlow. It's from the University of British Columbia, but I think there was a Cambridge connection also. That's why it's called CamFlow.
I'm trying to remember. Do you know what type of label operations it perform? Is it just sensitivity, or is it also, does it have sensitivity and privacy labels?
So the base system is just a label propagation system, right? And your labels are 64-bit values. You can feel free to assign semantics to them. So it's going to propagate labels at the level of OS level artifacts, things like processes, sockets, files, and so on. So that's what that is.
Well, one thing you have though with simple labels is the inevitable label creep, where
yes,
as information propagates through the system, it achieves a level of sensitivity that is almost like no longer usable, that no one can access because everyone's touching it. And then you have to have some kind of means of declassification. So you can imagine your filter operation receives a highly sensitive topic and then has to declassify that. And then, you have to account for that declass. Is that something that the Linux project already does?
No. The Linux project is just basic infrastructure for label propagation. Now, you can sort of bless certain applications for declassification. And that's what we are doing, right? I mean, we want to bring this notion of trusted applications that we refer to in this talk to also that problem there. First of all, we want to understand the problem of label creep in a practical ROS-based system, maybe like a real robot, to what extent is there label creep? And then sort of figure out how to design these trusted applications, where to place them, and so on, so that we can declassify the data flows. So all of those will be part of the empirical evaluation of this work once it's ready. But that's an excellent point. Yes.
Cool.
Actually, I have another question. Since I was going through the GitHub repo, and I've seen a lot of modification on the kernel, which it's pretty hard if you have update on the kernel and you need to bring the code here and there. So about that code, how much of it is necessary to be there, or is being incorporated that is not being completely written by you guys?
Yeah, so I guess Rakesh and Abhishek are the best place to answer that question.
Abhishek, can you take up this question?
Yeah, sure. So if I understand the question correctly, you are asking us how much of it is absolutely necessary for our system, right?
Yeah, because I've seen that a lot of modification are embedded inside the kernel, and I'm always concerned about those kind of modification. If something is modified at the kernel level, you need to bring everything in the new version and such. You're having a lot of code base that is hard coded. Is usually a pain in the ass to manage. That's the question. If it's all necessary, or is something that you included and you clone somewhere else or something. Yeah.
Yeah, absolutely. I understand that concern. I mean, that's why we tried our level best to make all our modifications within the security module itself. So, I mean, the LSM infrastructure allows you to create modules, right? I mean, in the sense, we're not touching the core kernel components like the memory or the networking subsystem, but we had to make a slight exception for the networking component because it was necessary to propagate the PID of processes through the network stack. So, for example, we tried doing this via netfilter hooks, but to our understanding, the netfilter hooks aren't in process context in the sense that at let's say the IP4 output hook, you don't know which process actually sent that packet. So we had to, sort of create a workaround which involved modifying the network stack, and that was very little actually. It was just about, I think not more than 30 or 40 lines of code. But apart from that, most of our changes are to, the security module, AppArmor's security module exclusively.
Are those patches you'd be willing to maybe push upstream? Because I think those are fairly valuable.
Yeah. It's all in the GitHub repo. It's completely open source.
I'm saying to maybe submit a pull request to the AppArmor codebase and maintainers.
To AppArmor?
Yeah.
Yeah, so that is something which will require a lot more work. We haven't thought about that, but certainly that is something we could explore. Yeah, thank you. We will definitely look at that.
Yeah, I think the wider community beyond robotics, I think would be very interested in that as well.
Right.
Yeah, so you mentioned policy construction and the onus of correctness currently on the user. One thing we have in the works with SROS is this concept of node IDL, where you have a description manifest describing what interfaces the node itself on a more abstract level in the terms of its interactions with the computation graph, what it requires, what it minimally requires for basic operation. And then that is something that we would use in the SROS tooling to auto-generate the access control permissions. And so we have something, a prototype where you can have an existing running system and then audit that system by taking a snapshot of the connectivity, the topic connectivity, and then translating that into a so Jeremy just put up the Node.idl docket, and then that's something that SROS would consume to generate the minimum spanning policy that then would translate to the DDS security artifacts. But like you said, it would take a little bit more analysis on the data flow to verify that you aren't leaking sensitive information through a side channel or that you left a loophole.
So this is upcoming, you said?
We have the policy generation. The IDL is still in. I think they have Canonical's been working heavily on that. They have a prototype and a design doc you can read right now.
I see.
So I think that's something that could probably be incorporated into this larger scheme of validation.
Right.
Certainly something me and Gianluca are really interested in as well.
So I'm just curious. So this is at the manifest level for each application, right? What you just mentioned?
Yeah, it's this sort of additional manifest that is authored on aside from the code base. There could be there could be, I think it might be pretty hard, some code analysis and maybe where you could acquire this manifest either through static analysis of the code to figure out what topics it's using, or again through runtime measurements. But that might be a more advanced topic. I think right now we're just thinking about where library maintainers who are domain experts for the sub-application that they're designing would then provide sort of default sane IDL files or Node IDL files that would then be appropriate for end users to incorporate when generating their unique security artifacts.
I see. But the runtime context of how the application is used, you still have to sort of take a snapshot of the system and extract it, is it?
Yeah. So, I mean, the sort of an inherent difficulty in secure DDS in that the permissions are sort of static. Once you've loaded the DDS participant and it's acquired its credentials, the default plugin at least doesn't have a means of changing that dynamically, which makes it easy for this decentralized governance, but that rigidity, it's not quite as flexible. There's been discussion with some DDS vendors on how we may be able to update. So if a say a Ros node finds that it needs to dynamically subscribe to a new topic, it could self-update its own credentials if it had a key server request mechanism of contacting a CA for new credentials. But that's a bit far in the future.
Okay.
I think the patches though, this indirection seems pretty tough to I'm not sure if we would be able to upstream that into RCL CPP. Would it be more sane to eventually take the approach where you would be explicit on these redirections for sanitizing the data in the launch file as opposed to having the flow controller?
Yeah, so this is one of the things that we were trying to work. One of the constraints that we were trying to work within was, if you had a commodity or off-the-shelf SROS application with a manifest that was baked in, then how do we get everything to still work? If you had the ability to, let's say, tailor the manifest files to a particular communication graph or to a particular scenario, you don't need to go through all of these things, right? Where you have these additional topics and so on. So all of these things arise only because we were working within the constraints of existing applications and baked in some sense, manifest files, where we can't really change the manifest files without issuing a fresh certificate for the application. Does that make sense? Yeah.
Yeah, because the entire stack is cryptographically signed.
Right.
Exactly. You can't change anything on the disk, and you still need a way of modifying it post.
Correct. So that was a design consideration as well that went into the system. I mean, clean slate, right? Yeah, you can just say, look, this is the communication graph I want, and then go top down, generate all the manifest files, and that's all. And then you issue the certificates for the applications. It all works within the SROS framework. But of course, you still have to do OS level enforcement in case there are any malicious applications that try to communicate outside of the DDS and ROS framework. But that's the AppArmor stuff. So ROS alone, if you had the ability to go top down, that's what we would have done. But we also wanted to have the ability to support existing ROS applications while only probably minimally requiring this additional topic. And so that's the reason we did things the way that we did.
So you guys are using ARM Trust Zone and the Jetsons. Oh, what's your experience with that?
So Rakesh can share some stories, I guess. Yeah.
So you mean to know about the documentation regarding the ARM Trust Zone?
It's something that the working group has been interested in, like having a DDS plug. Like I think ARM was working on a little project for a while and implementing the DDS security plugin with ARM Trust Zone. But I just wanted to hear your thoughts on the merits, the benefits, and maybe any difficulties you had in working with those features.
So one thing I must clarify is that our use of the trust zone was only for the purposes of attestation, in the sense of attesting the normal world where ROS and everything runs. We didn't build anything. We didn't incorporate any ROS components inside the secure world, if that's what you're asking.
Yeah, I remember that from the paper. I was just more in general.
Yeah, the main problem with NVIDIA's adjacent TX2 is lack of the documentation, and also the form support is not that good. So in the beginning, it's a bit of a struggle to know what exactly is happening, how does a normal world communicate with a secure world. Once these things are known, then it becomes easy. But it's a little bit of struggle to get started with the trust zone part.
To what extent is the attestation? It's verifying that this is my file system. This is the processes that have been launched from the executables on this file system. What else do you end up having to verify or to?
That's it. Anything static is what we are doing right now, which is, in some sense, it's an overkill for trust zone. I mean, we are doing standard TPM-like attestation right now, but we want to make richer use of the trust zone. So if you're familiar with Samsung Knox, the technology they use to protect the normal world at runtime by shepherding sensitive operations through the secure world, We were trying to mimic that for a while outside of this project, of course. But that's not described in this paper. In this paper, it was mostly just the Privaros side on the normal world with bare bones attestation, just to show that, in the sense that without a root of trust, a hardware root of trust, you can't really trust anything on the drone. So we took the bare minimum root of trust and did attestations which are TPM-like. Of course, that has known problems also, time of check to time of use. You might measure everything, and then the adversary may replace the software stack on the drone. So as it stands, as described in the paper, we are vulnerable to that. But Samsung Knox-like enhancements, which is basically a bunch of kernel enhancements, would allow you to prevent that to a larger extent than we currently do. So even Samsung Knox is not perfect, though. So I don't know if that explanation made sense. But the Knox technology is also described in another paper from 2014. It's called Hypervision Across Worlds. So they describe how kernel modifications can extend to beyond just spot checks that are obtained from attestations. You can extend it to kernel lifetime integrity, modulo certain guarantees.
Could you repeat the paper? Something across worlds?
Yeah, it was called Hypervision Across Worlds. That describes the basic technology that goes into Samsung Knox, which is what is found in all our phones now. It's called Hypervision Across Worlds, and then there was something else in the title, I think real-time kernel integrity protection or something like that. But it was from a team from Samsung at CCS 2014, if memory serves.
All right. Thank you. Anyone else have any general questions or topics they want to discuss? Well, it's a little past the hour, so I don't want to keep people for too long, but feel free to contact the speakers if you have follow-up questions. I want to thank the speakers for coming and giving this awesome talk. And then you guys are also presenting, is it Thursday or Friday at the Cybersecurity Robotics Conference?
No. This was at our work was presented at CCS in November.
Yeah, the original publication. I'm thinking of the announcement that I think Deber put out on Discourse. I'm sorry, let me go get it.
No, not to my knowledge, at least. So.
Maybe I'm misremembering. Drop the link. You'll certainly. Everyone here is attending will probably be interested in this as well. It's happening later this week. Here we go.
Okay.
All right.
So,
I just want to say thanks. I appreciate Ruffin for setting this up, and thanks to the members for presenting. Again, like Ruffin said, I think it was really interesting and valuable as well for us. Are you able to share the slides that you presented so I can upload them for the group?
Yeah, let me just share a link to the paper and to a shorter version of the slides. Rakesh can post everything. So we also have like a demo video and all that. They're all at this link right here. I just posted it on the chat window.
Great, thank you. And then Ruffin, if you have the video afterwards, if you shoot me the link, I'll drop it in the notes for today.
Will do.
Thank you.
I'll also update the OP post. People can find it as well. All right. Thanks for coming, guys.
Yeah, thank you. And any feedback, we are more than happy to hear from the community. Please feel free to just write us email. All our contacts are in the paper. Thank you so much for inviting us.
Thank you.
Yeah.
Thank you for the speech.
Thanks.
Yeah, thank you for the presentation.
Bye bye.
Bye. Thank you. Bye.
Bye.
Thank you.
Bye-bye.